I'm Von Gregory A. Pancho, and my topic is twist on the mean on a normal distribution variance unknown. So it is assumed that the mean systolic blood pressure is M minus 120 mmHg. In the Honolulu Heart Study, a sample of N minus 100 people had an average systolic blood pressure of 130.1 mmHg. With a standard deviation of 21.21 mmHg. The group significantly different with respect to systolic blood pressure from the regular population. So the null hypothesis is HO when equals 120, and because there is no specific direction implied, the alternative hypothesis is HA M or unequal 120. In general, we know that if the data are normally distributed, then we use the formula P equals x bar minus n over s square root of n. Follows a distribution with n minus 1 degrees of freedom. Therefore, it seems reasonable to use the test statistic. So P equals x bar minus n0 over s square root of n. So for testing the null hypothesis, H2, H0, and N equals N0 against one of the possible alternative hypothesis, HA. So N equal to N0, HA, mean than N0 and HA, mean greater than N0. For the example in hand, the value of the test statistic is equals 130.1 minus 120 over 21.21 root of 100 equals, the answer is 4.762. So the critical region approach us to reject the null hypothesis at the A equals 0.05 left level if T greater than or equal to T 0.025 0.99 equals 1.9842, or if T is less than is equal to T 0.025.99 equals negative 1.9842. Therefore, we will reject the null hypothesis because T equals 4.762 greater than 1.9842, and therefore falls in the rejection region. So there's the graph. So the left side is negative 1.9842 and the right side is 1.9842. So 99. And then as here it's we do the same conclusion using the p-value approach. The p-value approach lets us to input the null hypothesis of the A equals 0.05 level. If the p-value probability value is less than is equal to A plus 0.05. In this case, the probability value is 2 times probability 299 greater than 4.762. Less than 2 times probability 299 greater than 1.9842 equals 2. 0.025 equals 0.05. So, long graph. So, the left side is 4.762 and the right side is 4.762. So, expected to reject the null hypothesis because probability value less than is equal to 0.01, less than A equals 0.05. Then we'll learn how to ask method to conduct the thesis for a mean in a book. But this is what the method output for this example looks like. So, first of mu 120 versus not equals 120. So, now 100 mean 130.100 standard deviation 21.1 gram So mean 2.21, 95%, PI 125.891, and 134.279, and the P is 4.76, and the probability 0. So, anyway, the decision for the null hypothesis is consistent with the one we would make using a 95% confidence interval using the data. A 95% confidence interval from the mean is x bar positive negative p 0.025.99 s over square plus 1 plus 132.1 positive negative 1.9842. And 21.21 over root of 100 is simplified by 30.1. Positive negative 0.21, that is we can be 95% confident that the length systolic blood pressure of the Honolulu population is between 125.89 and 134.31 mmHg. So how can a population living in the climate with consistently 80-degree volts have elevated blood pressure? So anyway, the typical zone of the with the O equals 0.05 hypothesis help us to refute the null hypothesis that mean equals 120. Mean equals x squared minus n0 over L squared plus n greater than is equal to 1.9842. So it's 3 x squared minus n0 over x squared plus n. Then it's equal to 1.9842. So that is equivalent to rejecting is x squared minus n0 greater than is equal to 1.9842 plus square plus n, or is x squared minus n0 plus then is equal to 1 negative 1.9842 and s over square plus n. So which upon inserting the data for this particular example is equivalent to rejecting n0 plus equal to 125.89, but n0 greater than is equal to 134.31, it just happens to have 12 points of 94% confidence interval for the main and the reserve part of this.
Good morning, everyone. I'm here to present my topic 8.1.2, or the p-value in hypothesis test. So, by the way, my name is Mully Frederick Mul S. So, first, p-value. P-value, the probability the test statistic would take a value as extreme or more extreme than observed test statistic when null hypothesis is true. Smaller and smaller p-values, stronger and stronger evidence against null hypothesis. Conventions for interpretation. P greater than zero point 0.1, evidence against null hypothesis not significant. 0.05 less than, or it is called, if P is greater than 0.05 or less than is equal to or equal to 0.1, evidence marginally significant. And if P is greater than 0.01 or less than or equal to 0.05, evidence against null hypothesis significant. And the last one is, if P is less than or equal to 0.01, evidence against null hypothesis is very significant. Illustrative example. So as you can see this, the normal distribution, if the z statistic is equal to 3.23, that is the, the graph or the normal distribution. One-sided P is equals to P, open quantity Z greater than 3.23 plus quantity is equals to 1 minus 0.994 or equal to 0.006. Very significant evidence against null hypothesis. So as you can see this from the right side. Another one is the significant level. This is the uh, alpha sign threshold for significance, or we set the alpha. For example, if we choose alpha 0.05, we required evidence so strong that it would occur no more than 5% of a time. When null hypothesis is true, decision rule P less than or equal to the alpha, or it is called the statistically significant evidence. And if the P is greater than alpha, non-significant evidence. For example, if we set alpha 0.01, a p-value of 0.006 is considered significant. Though the summary is this, for example, mean. Draw an SRS of the size from that normal distribution that unknown the mean or and non-standard deviation, or that is this is the symbol of standard deviation. And to test the null hypothesis that mean has specified value. So null hypothesis is equals to null value, null mean. Calculate the sample z statistic. So mao ni ang iya process. Statistic value two-sided test. Hypothesis, test statistic, and p-value. Relation between test and CI is for two-side test, significant result and C level, null mean will fall outside, or 1 minus A or times 10% CL. When alpha is 0.05, this is the solution, or the answer is 95% confidence. The other one is 99% confidence. Recall that we tested null hypothesis, the mean is equals to 0, and found the two-sided P and 0.012. Since this is significance at A is 0.05. We expect 0 to fall outside that 95% confidence interval continued. Relation between test and CIs. Recall X bar 1.02, N is equals to 10, and variance is equals to 1. Therefore, 95% CL for mean, kani ang iya formula, and we come up 0.40 to 1.64. So positive ra ato kanon kwaon, since 0 falls outside this 95% CL. The test of null hypothesis, or the mean 0 is significant at the alpha 0. Or 0.05. So this is the example, no? Example 2, job satisfaction. Does the job satisfaction of assembly worker differ when their work is machine-based rather than self-paced? A match pair study was performed on a sample workers. Worker satisfaction was assessed, and each sitting the response variable is difference in satisfaction scores. Self-paced minus machine-paced. The null hypothesis, no average difference. And a population of workers, the alternative hypothesis is there is an average difference in score in population. So, ana ang yes? Illustrative number 2. So, kanina another example, no? Kanina value given A. So ano na ta sa another example na sa isira ni siya. Sa kaning example, consider the question asked is given one is acceptable, answer yes or no. Remember, could you please repeat this question? Green, not car, green Honda with a sunroof, New York license plates, and radio was blaring. What is this test? So, same magyapon. So, for more information or for more details about this topic, so mao ni ang iya website, pwede ra mo open. Kani ang table process a large and makes everything significant. Suppose 31% American household apakat. Suppose we test null hypothesis, the P is 1/3 and the A hypothesis P is not equal to 1/3. Monia process. So we come up the very strong evidence because it is the result is 31% not equal to 1/3. So this is the graph, no? Itong problem ganiya. Different ideas. This is the table ganiya. This is the problem. What is bacteria? So ammonia process that we can come up mean and control mean of our group is 4.750 and 32.429. What the standard deviation of request method? So we'll proceed to the next topic. So my next topic is the general procedure for test of hypothesis. So for the 8.1.3. So the step 1. State your null and alternate hypothesis. After developing your initial research hypothesis or the prediction that you want to investigate, it is important to restate a null hypothesis and alternate hypothesis so that you can test it mathematically. The alternate hypothesis is usually initial hypothesis that predict a relation between variable. The null hypothesis is the prediction of no relation between the variable you are interested. Hypothesis testing example, you want to test whether it is a relationship between gender and height. Based on your knowledge, the human psychology of your formulate hypothesis that men are on average taller than women. To test this hypothesis, you restate as an kani. The hypothesis men are on average not taller than women. An alternate hypothesis men are on average taller than women. Step 3. Perform the statistically statistical test. There are a variety of statistical tests available, but they are based on comparison within the group variance. How spread our data in within the category versus between group variance? How different the categories are from another? If between group variance is large enough, that is, the little or no lap between the group and statistical test will reflect the slow p-value. That means unlikely the difference between these groups came about by chance. The next one is step 4. Decide whether to reject or fail the reject or null hypothesis. Based on outcome of your statistical test, you will have decide whether to reject or to fail the null hypothesis. Step 5. Present your findings. The result hypothesis will represent the result on section research paper dissertation thesis. So that's all of my topic. We'll proceed to my other member discussing the topic test mean and normal distribution variance. No. So thank you for listening.